just joined us, we have just started recording the webinar, and therefore we ask that you keep your microphones muted throughout the presentation just to avoid any feedback. But of course, we then invite you to unmute yourselves should you have any questions at the end. Now, before I introduce our speaker for today, I would like to acknowledge that the land on which Concordia University of Edmonton is located is Treaty 6 territory and a traditional meeting ground and home for many Indigenous peoples. We respect the diverse histories, languages, and cultures of First Nations, Métis, and Inuit communities that enrich this land on which I live and work. I invite you all to acknowledge the land and territory that you are located on at this point. We're very excited about today's webinar. It is being delivered by Michael Wiggin. The title of the webinar is The Value of Thermal Energy Networks in Creating a More Sustainable Decarbonized Energy System. Now, before I pass it on to Michael, I want to give you a little bit of background about our speaker today. So after working as a consulting engineer for 8 years, Michael served as director of the federal government's Community Energy Systems Group, advising on and expediting district heating projects across Canada. Most recently, he was an advisor to the $1 billion stream to hot water conversion of the government systems at the National Capital Region. He's now senior advisor to and past chair of the International Energy Agency's Executive Committee in District Heating and Cooling R&D. He's also a member and deputy chair of the Ontario Society of Professional Engineers Energy Task Force with the focus on the affordable decarbonization of electricity systems through synergies between thermal and electricity networks. Since 2016, he has been an adjudicator for the Global District Energy Climate Awards, sponsored by Euroheat and Power, a major European trade association. He's worked closely with Canada's municipal sector. He helped establish the evaluation process for the Federation of Canadian Municipalities Green Funds program and helped the Greater Vancouver Regional District prepare the 100-year Sustainable Development Plan that won first place in the 2003 International Sustainable Urban Systems Design Competition. So without further ado, I pass it over to Michael. Michael, you are muted, sorry.
Yeah, sorry about that. Yeah, I'd like to thank you all for coming today and for the opportunity to speak to you all. We did have a bit of a glitch in the computer system, so Carla has gracefully offered to walk through the presentation for you. The other affiliation that wasn't mentioned perhaps by Carla was I'm a director of the Boltzmann Institute. We've got a group of like-minded people that have worked together over the years. We were concerned with some of the directions we were going, like the electrification of everything, including building heating. We were concerned about the impact on the electric grid of these moves. And so we formed our Boltzmann Institute to research these issues and put forth information on it. And at least one of my colleagues is with us today, Martin Green. So I'd like to get on to state, first of all, today my main objective was not try and tell you anything, lecture on things, but I wanted to engage you in thinking about some of the challenges that we all have, because society needs all the environmental activists and engineers to start developing a shared pathway. Because if we argue in front of the public with each other all the time, it gets a bit confusing. So I'd like to contribute to that discussion. Next, Carla. Next slide, Carla. Okay, so first I'd just like to give a quick overview of thermal energy networks. These are now quite common in Europe. In fact, about 60% of the northern countries, the buildings are served this way, about 60% buildings. In cities like Copenhagen, Helsinki, and Stockholm, is about 98% of buildings. So this is doable, it's commonly done. But the main thing is we have electric grids, we have gas grids, we have water and sewer grids, but we do not in Canada have very extensive thermal grids. Now, the thermal networks, it's coupling together sources and demands of heat through a set of underground piping. These are pre-insulated, very little energy losses on them. And what they're finding in Europe is these grids, while they're rare in Canada, serving only about 2% of energy, they found that about 60% of a lot of regions, 60% of the buildings at least, can be serviced this way. So, so it's not something new. It's not earth-shattering. It's being done. The next thing I think is really important is that we are having trouble with our efforts to decarbonize buildings. We're focusing on energy efficiency, looking at deep retrofits, and we're looking at putting in heat pumps to meet the heating load. However, this is going rather slowly. We're supposed to be decarbonized by 2050, and at the rate we're going, it's going to take a lot of time. So what's interesting about having a thermal utility is that it transfers the responsibility from the building owner to the thermal utility. Now they have the responsibility on your behalf of finding decarbonized sources. And fortunately, there's a lot out there. So if we can follow this idea up, we should go beyond looking at building efficiency and building-based renewable energy to taking a societal view, the society or community's efficiency and renewable energy use. And we may find there's lots of opportunities there. So Carla, next slide, please. Okay, thermal networks. Just a picture of them. These are quite different than the older steam systems done years ago, where they had to have tunnels underground for the steam pipes, things like this. Now with pre-insulated pipes, they're able to bury them only about 2 feet below the surface, about 60 centimeters. And the worry is structural protection. The heat loss isn't an issue. The insulation's so good. So to cut into a road or a sidewalk and put these pipes down, they're usually above all the other utilities, water, sewer, and so forth. And so you can often go above other utilities and put them in without too much difficulty. I showed a few pictures for smaller diameter, in fact, from about 100 millimeters and less. They're now supplying with PEX pipe, so corrosion isn't an issue, and they can supply them in rolls, as shown in the picture there. So places like Ujebugumu, a community I work with that's had district heating since about 1992, most of their piping is of this form, coils of PEX pipe installed by people within the community itself. Next slide, Carla. Okay. Now, often we get into arguing details of one method versus another, but I think it's really important to come back and focus on our common ground. All of us, I think, are concerned about climate change. It's very evident now. All the climate scientists are behind it, and we are seeing the risk through forest fires, flooding, derechos, major storms, hurricanes. It's very evident we're on this path. So, and now we've got challenges. We do have to reconcile what about these climate change concerns and the need to eliminate greenhouse gas emissions. And at the same time, we're talking for economic reasons, expanded fossil fuel production. The world still needs a lot, and so our economy benefits. Anyhow, we've got to reconcile that. We can't keep burning fossil fuel and mitigate climate change at the same time. Now, the next thing I'd like you to think about is that when we talk of energy, everybody talks about the cost of making energy, whether it's solar or wind or anything. And they talk about the amount of energy used. Now, it's often easy to balance the seasonal output of solar collectors, let's say, with your seasonal heating demand. But what about the peak? At some time of the year, or the coldest days of the year, you have to meet a peak demand. And this is quite different than the average during the year. So we've got to look at this. So keep some of these things in mind and think about the type of things you're working on and think about how you can meet these challenges. Next slide, Carla. Next. Yeah, okay. So as I said, I'm going to show you some of the stuff that me and my colleagues have been working on, but I mainly want to get some discussion so we can work together, all of us, on developing a common understanding of how to move forward. So I identified some of the major challenges, but now let's look at an integrated way of getting there. Building heating, I'm going to focus on that because it's a really big issue. It's about 20% of our greenhouse gases nationally, and about 70% of the buildings that are doing these emissions, they're still going to be here in 2050. So while we are making a lot of progress on net zero passive house design for new buildings, we've got a lot of buildings that are here now and they're still going to be here in the 2050. The other thing is the rate of deployment of our housing retrofits is not really going to get us to this target. It's going slowly. And what people are finding is as you push beyond the initial reduction in greenhouse gas, the cost for existing buildings starts going up quite sharply. And then the other thing I said, some of our solutions are counterintuitive. As a building owner, the most obvious thing to do today might be to put in a heat pump. However, we've got to step back and say, where is that electricity coming from? Who's going to build the extra capacity? How is it going to be paid for? This is a very complex issue, but to simplify it, I'd say for Ontario, the current peak load, and we'll come back to this later, for the existing electricity system is only about 23%. The peak load for heating buildings using gas, sorry, it was about 23 gigawatts, I should have said. The peak load for meeting heating on natural gas is somewhere in the order of 70 gigawatts. So if we're going to electrify what's on our gas system now, we're going to have a very different electricity system. And the idea of tripling or quadrupling your electricity system and the distribution systems, it's very, very difficult to anticipate, and the cost is going to be very high. I'll come back to this. Carla, next slide, please. Okay. If you're not familiar with it, I'm going to use low duration curves a bit in this presentation. If it doesn't make sense to you, imagine taking your hourly heat load during the year and look at a plot of hourly heat load, and then take those hourly heat loads and rank them from the highest to the lowest. And then you will get something called a low duration curve that looks like the blue curve. So the peak is very, very high, but for a very short time, the 100% of peak, but it drops off very sharply. It's only that cold for a few days, number of hours. It drops off sharply, and then during the summer, obviously, the load drops to almost nothing. Now, that is not an easy thing to deal with. When you have natural gas or oil, it's not so bad because the boilers are cheap and the fuel's available. We've got the infrastructure. So you turn on your furnace or boiler and meet the peak. But if you take away fossil fuel, it becomes a very different challenge, okay? So the other thing I'd like to say is that if you switch over to heat pumps, this is a little debatable, so don't take me 100%, but basically the peak energy requirement for heat load and a resistance or heater backup furnace is similar. So even though cold weather heat pumps are getting the COP up, the efficiency up during colder weather, their capacity drops. They have to make up the difference with gas or electricity. And if we're going to decarbonize, it'd be electricity. So, but looking at our low duration curve, even though the peak is the same, through the average efficiency of a heat pump, let's say 2.4 for an air source heat pump, seasonal, you get a lot less electricity requirement. It drops compared to medium resistance heating. So this means that the utilization of that peak capacity is only about 10% of what that peak capacity could put out. So if you're asking an electric utility to serve that coldest day of the year, but only use that incremental capacity for 10% of the possible energy, it doesn't work economically. So they have to jack up prices to pay for that poorly used incremental capacity. So this is what I mean. It's really important to move from your comfort zone and looking at your own building to moving beyond that and asking, how does the electricity get there? Where does it come from? What are they going to have to build to serve our future heat pump needs? So it's this kind of concern that caused us to look for other examples of how to do it differently. Carla, next slide, please. Okay. So with this peak load issue for heating, as I showed you, it's very different than normal electric loads. If we're going to decarbonize the building sector, there are many sources of heat or electricity available, but they're variable, like weather dependent, solar or wind, or they're available when they're not needed, like industrial waste heat, solar heat in the summer, or heat from power plants. So there's always a big mismatch between the peak loads you've got and what's available. So whether you go for a thermal system or an electric system, meeting peaks is going to be really, really difficult without storage. Now, if we look at storage options, they're making great advances in batteries, pump storage, and everything. But thermal storage, I'll show you, is much cheaper, possibly about 1% of the cost, and it's been done at large scale around the world. So generally then, producing heat is much cheaper than producing electricity, and storing heat is much cheaper than storing electricity. And technically, you can't store the electricity for very long periods in big amounts, but heat you can store seasonally, in fact, almost up to a year, and I'll show examples. So we can, right now, if people say we've got a peak problem with using heat pumps, say, oh, we'll use natural gas for the backup for peaking. That's fine, but if you reduce the gas company's business to about 20%, they won't do that for the same cost. And also, this isn't truly decarbonized because you're still using, let's say, 20% of the gas you used before for decarbonizing. Next slide, Carla. Yeah, okay. Energy storage. If you look at that low duration curve, it's got a seasonal high peak. Now, for this example, if you go to about 40% of that peak and say I want to store the heat above that, it only amounts to about 15% of the annual energy load. So if you've got sources that'll give you 40%, there's many times a year when the load's less than that, and you can store surplus energy. So this is just a simplified example to show the impact storage has on reducing peak demand and making better utilization of our the capacity we've got. You can do variations on this if you've got intermittent sources or seasonally available sources like solar thermal, for example, that put out lots of heat in the summer, less in the winter. They can benefit from these concepts of thermal storage. Next. Some examples. Markham District Energy, one of the more progressive systems, in Canada. They've got multiple sources, biomass, cogen, geothermal, heat from sewage, and they use storage by this tank you can see on the right of the drawing, a big water tank, very simple. And when you go in Europe, you see just about every town has one of these where they store heat so they can shut down cogen plants on the weekend and just supply the needs of the community out of that storage. Or they may go to something longer term. Carla, next slide, please. Okay, here's one in Denmark where they've got in the background, you can see a big solar farm, and then they're able to store that heat in a pit. It's basically a deep pit, it might be about 15 meters deep. It's insulated on the sides, and it's got a floating insulated cap. So that's one. It's called pit thermal energy storage, and there's quite a few of these around the country. Next slide, Carla. A really interesting one recently is in Vanta, Finland. They built specifically for thermal storage some large underground caverns, about 100 meters underground, 1.1 million cubic meters, and it can store heat up to about 140 degrees C because of the pressure. And it can provide over 90 gigawatt hours of heat. That's enough to heat some smaller cities for a year, okay? And compared to the same amount of energy stored as electricity in car batteries, be about 1.3 million car batteries equivalent at about 1% of the cost, okay? Now, I'm dealing with China right now, and they've got one double the size, 180 gigawatt hours of thermal storage. And it turns out quite economical. Next slide, please, Carla. I should mention there's some other developments like Canadian developments. You may have heard of Okotoks, Drake Landing out in Okotoks, Alberta. They had a smaller thermal storage with boreholes, drilling boreholes in the ground, putting the heat down there, storing it in the ground, taking it back in the winter. And they could meet 90% of the heating load with the solar collectors. Now, this was a relatively small one, but they're building bigger ones that are more efficient. And they've even got technology now where they can go into an underground parking lot and drill holes below that and store heat below existing parking lots. Yeah. Sorry, there's an oversight. I forgot a photograph of that. Now, coming back to this, there's some work done by my colleague Martin. And the blue line, if you look at the left diagram, it shows existing existing electricity load over 2 years for the Ontario electricity system. And then on top of that, we took to heat that, if it was resistance heating, what would the additional heat load look like? So in the extreme left diagram, that shows 2 seasons showing the existing heating load, the existing electric load and what it would look like if you added on electric heating for the heating. The next diagram in the center shows the electric load for 2 seasons, and then it shows what the electric load would be like if you used air source heat pumps. Okay, so it's still the same peak, but you can see the area or the volume of electricity has gone down. Now, the third scenario is you use thermal energy networks for about 70% of buildings, urban areas, and then you have to allow about 5% for pumping energy. But then for the rural areas or the 30% of buildings, you use ground source heat pumps, which are more efficient than air source, and also the impact on peak on the electricity is much less. Then that would show you what the adjusted electricity impact on the electricity system would be. So if you go to an electric utility and say, which one of these 3 could you deal with? and what's the relative cost of supplying them, you will find out that they get quite worried. In fact, you'll see in the ISO, the Independent Electricity System Operator in Ontario, they've done their outlook, and without really allowing for much heating, they are predicting a 75% increase in generation capacity, and they allowed for something like 400,000 heat pumps. Now, 400,000 heat pumps is about 7% of existing buildings. So we've got this problem. We've got governments that are promoting electrification of heating, and then we've got the electricity operators saying, I'm not sure we can do that in a way that's affordable. Okay. We have had some recent work that will be reduced soon that shows that the electricity price, if you had to meet the heating load of the electricity with heat pumps, it might drive the price up in the order of 250%. I'll come back to that one. Okay, next, Carla. I just thought I'd show this other one that it would have been better beside the others, but if you use gas for peaking at peak, you can bring down your impact on the electric grid quite substantially, bringing it down from about 70 gigawatts to about 35, but the electric utility would only sell about 20% of the gas they're selling now for heating buildings. So you ask yourself, if the electricity company's got to boost their capacity and the gas company's losing revenue and has to pay for infrastructure, they're probably going to have to start increasing gas prices as well. Anyhow, but it's a complex issue and we need everybody to start thinking about it. Carla, next slide, please. Okay. One of the general things I thought I'd pass on is the Swedish Heating Academy. They developed this philosophy. It's called 3 C's. One, we all want to conserve energy. Like, don't think I'm trying to replace being efficient with other sources of energy. But there are economies of, as you try and reduce the building consumption, too much gets expensive. So look at what's reasonable for lowering energy demand and lowering the temperature required to heat buildings. So conservation is the very first thing. So we're all on side there. The next was connecting to a thermal network, just like we used to connect to a gas work or connect to an electric network, connect to a thermal network. Even if in the short term, it might be using gas or whatever to supply that network. Once you're connected to the network has much more possibility for finding decarbonized sources. Also, it saves you a lot of headaches of looking for how to get deep retrofits, how to change your electric panels, put in heat pumps and everything, so that it transfers responsibility to the thermal utility, and the thermal utility on your behalf can find decarbonized sources and also get economies of scale and storage to get much higher levels of load management. And then the last thing, of course, is then convert those network sources to decarbonized sources. So that philosophy, I think, was good because it acknowledges the importance of efficiency at the building level. It also is committed to using reject heat efficiency, using renewable energy, but doing it at a community basis rather than only at a building basis. And then it's also committed to phasing out fossil fuel and putting in renewable or waste heat resources. Next slide, please, Carla. Okay, so in our work, I just say something about the what's happening now. Based on trying to promote and discuss these ideas, the Boltzmann Institute got a contribution of about $750,000. This was through the Net Zero Advisory Board, and it's given to us by Environment Climate Change Canada. And we are comparing an electrification pathway with a thermal network pathway where feasible. And this report should be complete in about a month, and it'll be circulated to all the local distribution companies in Ontario and be available. And what it's showing basically is that when you take into account full cost accounting, the electrification option is considerably more expensive than the thermal network option. Within the Ontario Society of Professional Engineers, they've been looking at priority areas for investigation and advocacy, and they've identified thermal network strategy as one of their priority topics for 2024 and again for 2025. We've been working with the Nuclear Association Advisors, McMaster University, and others, looking at issues like nuclear CHP. And that's been a very interesting one because it's happening around the world. And they're using, in places like China, using North American, like Westinghouse reactors, but building them in a cogeneration mode or combined power mode. And this is an enormous source of societal inefficiency. The waste heat from nuclear plants in Ontario is greater than the total building load, heating load of all buildings in Ontario. And we're going to be expanding it. So if we can change the planning to using heat from future reactors, that will create an incentive to build networks, and then the networks can use renewable energy, waste heat from other sources, and big thermal storage. It was interesting too, I found out through a British organization that the cost at the design stage of designing a nuclear plant so you can use the heat at some time in the future, putting in extraction ports from turbines, so forth, is less than 0.2% of the capital cost. So if we can get the nuclear industry to consider what to do there, we might be able to tap into a massive source of decarbonized heat in the future. So also we have been working on heating planning with some municipalities. We had a workshop in Toronto recently, and there's a great interest in this, and we brought over some experts from Germany to show what they're doing there. And in EU now, they are requiring municipalities, over 3,000 people, I think it is, to implement some form of, 30,000, to implement heating planning, look at the resources and see how they can use heat better. So anyhow, so within municipality and the GTA and the regions there, they're all committed to working more on heating planning, possibly cooperating with some of our European partners to incorporate what they've learned, not just methodology, but also policies within the EU and EU countries, and see what we can do further. So anyhow, so I think there's a lot going on, and we're perhaps at a tipping point of recognition of thermal networks being a very important component in our energy systems. And hopefully with this introduction, you can think about this a little bit and perhaps become familiar and see how it works in your communities. With that, Carla, I think I'm done. So next, yeah. So thanks again for the opportunity to talk to you all, and I'd be pleased to answer any questions.
Thank you so much for that, Michael. Should anyone have any questions or comments, I invite you to either just use the hand raise function on Google Meet, or feel free to type your comment or question in the chat, and I'm happy to read it to Michael. Any questions or comments at this point?
Yeah. Well, I hope it was clear what I was trying to point out.
Absolutely. I think maybe what I'll do as well, folks may be thinking of some questions or comments. Really appreciate the information you've shared. How feasible would it be to generate thermal energy networks in the province of Alberta, for example?
Well, you've quite feasible, I think. Back in 1991, Edmonton Power did a study to do their whole downtown, but they decided not to move ahead with it at the time. Gas was still very cheap, which is a problem we've had in the past. Calgary has put in a cogeneration-based device using natural gas, but making the power where you can use the heat. So part of downtown Calgary is already done that way. And they've done studies several other places, Grand Prairie and so forth. So it is feasible, but the problem is, I think it's awareness and consideration, because there hasn't been a big market. So the consulting engineers haven't focused on learning it. So when they're asked, could we do this? They hum and haw a little bit. So getting this into our professional community is really important. There is a company right in outside Edmonton. I'm not advertising, but FEB Engineering, they do a lot of the district heating design all over North America, and also in places like Dubai and so forth for big cooling systems. So I'd say it's quite feasible, but cheap gas is still the challenge. And now that carbon pricing has been set aside, that becomes a problem again. But the issue is, are we working on decarbonization or trying to find the least cost source? So with that, I would say it's possible, but it's still not necessarily very competitive if you're trying to compete with gas.
Thank you very much, Michael. We have some comments and questions in the chat. So we have a comment from Betty. Have thought that thermal energy is the way to move forward for a number of years. Glad to see this presentation to see what is feasible and hopefully will become the norm in the future. That's from Betty. We have another, now we have a question from Kyle Hofseth. And Kyle asks, could waste to energy systems be an option for the reuse of heat? This has been evaluated as an option in relation to net benefit, or has this been evaluated as an option in relation to net benefit?
Yeah. First of all, I think it'd be useful to mention the European example. They have these everywhere. And but they've come to the conclusion that the environmental impact of landfill sites is much worse. Well, it's bad. They see it as environmental time bomb. So they really invested in effective communication, so people understood what was possible, really good architecture on the buildings, and extremely good emissions control. So a lot of we're kind of locked into, let's say, 1970s opinions on waste energy when it was thought about, then discarded. But there's been so much advance in it that it's in Europe now it's seen as the preferred option. Of course, after you do all the recycling, reduction, reuse, recycle, but with what's left, they see a preferred option. And this is the principal market is heat for district heating systems. So if you pursue energy from waste strategy, you get rid of your landfill gas and fugitive emissions there, and you displace fossil fuel with the heat that otherwise would just go up as methane from your waste site.
Thank you, Michael. We have another question from Barb Van Ingen. She is Concordia University of Edmonton's Provost and Vice President Academic. So Barb states and asks, thanks for the presentation, Michael. Given the upfront infrastructure costs and the need for coordination across sectors, what strategies or policy mechanisms do you see as most critical for accelerating the adoption of thermal energy networks in urban areas like Edmonton?
Yeah. I think the first thing we need is, in government, let's say at the top, to start understanding these things and understand what they're doing in other countries. Because we don't require new technology, it's not speculative, it's not research. It's something that can lead to like guaranteed decarbonization. So if our governments understood that and started recognizing it in policy, it'd be very very, very helpful. I think that's one of the biggest things. Secondly, is providing more information on the relative costs and thinking of life cycle costing instead of just looking at your project. That's critical. Whether it's emissions or whether it's costs, we've got to start looking at societal costs. And I think once you start doing that, then people's eyeballs start opening up. Oh, I didn't think of that. I was just looking at, my building or whatever. So I think that's really critical. I think it's such a big change for us in Canada, even though it's like standard practice in Europe. I think it'll need some special mechanisms, like we've got infrastructure banks and so forth. And if we could start expanding those mechanisms, that'd be very helpful. But maybe one thing I would really emphasize is that there's lots of money around for investment, but it's a function of risk, right? So the municipality, its biggest asset is the ability to reduce risk. So if they recognize this as the best way, if they recognize this as a way to harvest reduced waste energy in the community, if they recognize it a way to make waste management more cost effective or whatever, then they can state they want it, look at the policies at the municipal level that would minimize risk, and they can then invite third parties that have the money and the know-how to come in some kind of partnership with your municipal utilities. In the past, it's often been the electric utilities. At the community's direction, they've given their electric utility a different mandate and said, we want you to look at energy, not just electricity. And this is a big barrier. A lot of groups across the country, they say, oh yeah, okay, we agree with the technology, but our mandate is this, right? And so they hide behind mandates not to do something. So I think a municipality can challenge, like they've done with NMAX in Calgary, and like they've done with EPCOR now in Edmonton, challenge them to reconsider their mandates and move from electricity to energy. And then they will see there's all kinds of synergies that the big benefit is actually minimizing expansion and increasing utilization of the electric system. Everybody understands the electric system and what it costs, and you can keep those costs down by integrating the thermal stuff. So I think I could expand on this later on, and I'd be very willing to with anybody that wants. But integrating, thinking of energy instead of just electricity in an integrated way, not separate ways, is critical. And municipality can do a lot there.
Sounds like maybe in a future webinar from you, Michael.
Yeah.
Well, we have a couple more questions, and I think this is all the time we'll have is for these two more questions. We have one from Stefan Portillo. He is one of our rock star researchers and faculty members here at Concordia. And so Stefan asks, what clean heat sources do you think are the most feasible for the Alberta context? Example, waste heat from industry, solar thermal, or natural gas cogeneration with carbon capture or something else?
Yeah, good question, because it's really critical for Alberta. And what I like about whenever I work in Alberta, there's a great can-do attitude. Can-do, like can do it, not can-do reactor. and it's really great. Just like NMAX did, they put in a power plant, cogeneration plant to that. But if you look around for other sources of waste heat, like cooling systems, in the future, we'll probably have data centers going in. These are certainly all available. You do have energy from waste. Some parts of the province have got biomass as an option. So I think if you did a heat planning exercise and started looking at what's being thrown away within your community and what will be thrown away, looking at future data centers or things, then you might reconsider your planning. Where do you put future data centers? Where do you put future power plants? And so on and so forth. And why are we doing landfill sites when we could maybe have something within the community that could be providing energy uses. So I think there's lots of sources there, not only what's there today, but what could be if you plan differently. So this is where I'd emphasize the importance of longer term planning. Just like we did in Vancouver, don't just look this year and compete on what's cheap. Look ahead 20, 30, 40 years and say, what kind of community do we want? And how could we design it better to maximize the benefits of heating planning?
Awesome. Thank you very much. We have one last question, and it comes from Leonard Eva. Leonard is developing a technology that generates and stores energy, and it also has a heating cooling capacity. Where can Leonard find a partnership? Now, while you were answering the previous question, I did ask if Leonard was in Edmonton. And Leonard, the reason I'm asking is there are options regionally, but there are also some options nationally. And so, Michael, I'll invite you to talk about maybe some of those national options that you may be aware of.
For now, I'd have to dig around a little bit more, but I do work within Enercan. There's a fellow that works on energy storage in general, a bit more on the thermal side. And he's been involved also internationally on the IEA at working with other countries and what they're doing on. So if you'd send me an email or through Carla, I can put you in touch with the people that I do know there. And that would give you some people that are in the business that may understand either funding sources or potential partners better. And that goes for anybody. If they've got any questions, either directly to me or through Carla, I'd be very pleased to follow up.
Thank you very much. And I've put our email address, mcneilcare@concordia.ab.ca, and we're happy to connect you to Michael and also send you some other resources depending on the region that you're in. That brings us to the end of our webinar. I first off ask you all to join me in thanking Michael for his excellent presentation. Thank you very much.
Thank you. My pleasure.
Appreciative. I also want to take the opportunity to thank all of you for joining us. And I want to do a particular shout out to Mr. Cam McNeil. You'll notice his last name is McNeil. He is the namesake of our McNeil Care Center. And so Cam is the vision behind this center. So thank you for joining us, Cam, as always. And I wish you all a fantastic, I thank you all for a fantastic rest of your day. And we're working on the next webinar in a month's time, and we'll send out some information in the next few days about that. So look forward to seeing you here all next month.
That's great.
Wonderful rest of your day. Thank you. Thanks again, Michael.
Thank you. Very welcome.
Yeah. Thank you all. Wonderful, Michael.
Yeah. Thanks, Cam.
Thank you very much.
Thank you. As said, if anybody's got questions,